All right, welcome to the video on writing algebraic equations. In this case, we're going to say equations just because we are going to be using an equation set. Sometimes you might hear expressions. Expressions we would use more if we did not have an equal sign. So I'm just going to use the right notation here and just call it writing algebraic equations. So in this particular case, we're going to use what we've just learned, which is about sequences, and we're going to apply that to the idea of generating an equation from that sequence. Okay, so let me first start out by making the connection between what we just completed. So arithmetic sequence to a table. So here we have an arithmetic sequence, and you can see that the common difference is 2. So what I'm going to do is I'm going to put that in the bottom here. All right, and I'm going to skip a couple just to show you an example of a couple things. All right, well actually let me put it one to this one. Okay, so 2, 4, 6, 8. Now, what I want you to recognize is that also we talked about terms in a sequence. So to reference that, we have term 1, term 2, term 3, and term 4. Okay? So let's just put those in the boxes on top of these. So let's say, for example, let me get a good color here. I'll use the black just to kind of say, yeah, let's use the green. So this is term 1, term 2, term 3, and term 4. Okay? Now I left these couple boxes open because I also want to show you the idea that we can, if you look at this, we have term 1, term 2, term 3, term 4. We can continue our pattern or our sequence in the opposite direction, making this 0 because we'd be subtracting 2 if we were going left, and this next one would be negative 2. Now this pattern also holds true for our top sequence of numbers in that even though these are terms, this is a 0 term and the negative 1 term. Okay? Now, I also, as you notice, left the last box open, and I'm going to replace this with x and y. And you're going to see why here in just a second. Okay? So, let's repeat what I just did. I took the sequence that we just were working with, which is this right here. Okay, this sequence of numbers. I put it in the table. I labeled it as the first term of the sequence, second, third, fourth. And then you'll notice I just continue that because I can show that it goes off infinitely in both directions. I'm just looking at this piece of the table. All right, so this is the sequence I worked with. I labeled the terms and then I just extended it. Okay, so hopefully we're seeing that connection. I want you to really make sure you're seeing that. Okay, so now what I'm going to ask you to do is actually generate an algebraic equation that would take whatever term we're talking about, apply it into the equation, and figure out what our result would be. So for example, if I said, in the case of one of your practice problems, what is the 52nd term in the sequence? Well, I don't want to sit here and just write out 52 numbers here, or in this case, 48 numbers to try to figure out what that is. I want to generate an equation that makes that quite easy. And like I've been saying in class, that's what mathematicians do. You know, in this case, we're looking at just a simple arithmetic sequence, but in their case, they might be looking at real data taken from a population in which they have to find a line of best fit to show that, and they have to write a function from that to hopefully make a prediction about the future. We're at the baby step stage here, but of course, if you're really good at that, that's definitely a profession you can achieve. So let's get back to what we're talking about now. Now I say write an equation. Now with arithmetic sequences, we're going to generate what we call a linear equation. Okay, now let's get back to our algebra concepts. You guys have heard of this, slope-intercept form, or in other words, y equals mx plus b. A very important equation in algebra and probably one that you've seen multiple times. So let's review some of the common traits of the slope-intercept form. And that is the m stands for the slope, okay, and the b stands for the y-intercept. Now I also want to make reference to the fact that the y-intercept is where it crosses the y-axis, okay, and that'll become important when we when we discuss kind of some of these tables, and we'll look at that. Now I also wanted to reference the idea that m, the slope, okay, I kind of wrote this in a different place, is that m associated with m in the slope is the change in y over the change in x, or you may have heard the phrase rise over run. Okay, both meaning the same thing. But we're going to mostly apply this change in y over change in x. That's going to be really important as we write these equations. All right, so let's just first out and look at the idea that how can I change whatever I plug in for the x, I get for the y. Okay, so you could kind of mess around with this a little bit. We noticed that, okay, well, every time I'm the top number, I'm multiplying this by 2, I'm multiplying this by 2, I'm multiplying this by 2. And so just by pure observation, we can come up with the expression y equals 2x, or my mistake, the equation y equals 2x, meaning whatever I'm plugging in for x, I'm getting a y. So for example, if 2 equals 2 times 1, that is a true statement, and therefore I can test that with all of the points on the in the x category, which is also labeled the domain, and I can associate that with the y column with the range. So whenever I plug anything into this equation that I generated, I get the number on the bottom. All right, so this is very important. That was just by guessing and checking. Our next thing we're going to do is really apply. We have the table here, a sequence of numbers on the bottom, and then we labeled the particular term it was. And so let's look at our idea here. Now, so first thing we're going to do is find the change in y over change in x. So we notice, what is the change in y? Well, it's going up by 3s. And what is the change in x? Well, it's going up by 1s. Okay, so my slope, and I'll write this in blue, is 3. So let's go over here and write down that what we just found out. So y equals, and the blue is going to be 3. Now understand these other terms, the y, the x, the equal sign, the plus sign, are not going to change. We're generating an equation, and the y and the x are the things that are going to change. Okay, these the 3, which is the coefficient of x, is going to be constant. Right, that's going to hold true so that we can generate an equation that can help us predict the 52nd, the 100th term, so on and so forth. Okay, so we found our slope, y equals 3x. Now we need to find that y-intercept. All right, so if we look at this, we see the y-intercept is also, I want to show this, is where x equals 0. Now in our particular table here, we see that, hey, well, where x equals 0, that's the y-intercept. Huh, pretty interesting stuff there. And so let's check to see if my idea works here. So 3x plus 6. So let's plug in a 3. So let's plug in 1 and see if this works. The first term in the thing, and we see that y equals 3 times 1 plus 6. All right, again, those are my slopes and my y-intercepts. So here you go. Let's erase this and this. I want to make those constant. Those never change. Okay, and the things I plugged in was I plugged in a 1. I'm supposed to replace this y with 9, so let's replace that. Okay, because I'm plugging in an x and a y, and so that's going to be 9. Pay close attention here. I plugged in the x for x, the 1, and I plugged in the 9 for y. Same column, same column. Okay, so then I see that 9 equals 3 plus 6, or 9 equals 9. So I know that this expression that I came up with right here works with this problem. Now let me just check it real quick. 3 times 2 plus 6 equals 12. 0 times 3 is 0, plus 6 is 6. So this is my equation that is helping me to predict the next terms. So for example, if I say what's the 100th term in the sequence, you can say 3 times 100 plus 6 and know that that is 306. That would be the 100th term in the sequence. Now when we apply this knowledge to application problems, you'll see why that's important. All right? So if you want to continue, this is part 1. Part 2, we'll work through the rest of these problems. Thank you.